All right, so we're going to start with chapter 1 and 2. So S is between R and T. You have to find RT. We do not know if these are equal because we don't know if this is a midpoint or not. It just says it's in between them. So what we have to use is the segment addition postulate. So with 3x and 6x plus 4, we're going to add them together and then set it equal to the entire segment, which is RT. Okay, so what we're using is RS plus ST equals RT, and that's what I have set up here. I made my line like this. So when you're on the same side, you add like terms. When you move terms over to the other side, that's when you're going to do the opposite. Okay, you will end up with x equals 2, but it's asking you find RT. So you're going to plug that back into the 14x minus 6 to get 22. 2 is different because it does tell you that this is the midpoint. So if this is the midpoint, then we know that each side is equal, which is why we can set 5x minus 6 equal to 2x and solve for x. So I got all of my x's on one side and then divided each side by -3 to find that x was 2. So if I'm going to find RT, I can first find ST by plugging in 2. 2 times 2 is 4. And then really both of these sides should be the same. So if ST is 4, then RS is 4. So 4 plus 4 is going to give you 8. This is probably a formula that if you don't know off the top of your head, you're going to want to write on your note card. This is the midpoint formula. Okay, so the midpoint is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is a point. Okay, so if you have to find the midpoint, you're going to add the two x's, -4 plus 10, which is 6, and then divide by 2, simplifies to 3. 1 plus -5 is -4, divided by 2, simplifies to -2. This is to write the converse of. One thing you might want to write down are what the forms are. So the conditional statement, okay, the conditional is if P then Q. The converse is if Q then P. So the hypothesis and the conclusion are going to switch. So if a figure has congruent diagonals, then it's a rectangle. And then 5 is asking for the contrapositive. Okay, so the contrapositive is if not Q, then not P. I also wrote down the inverse here for you, so if that was something you wanted to write on your note card, it's if not P, then not Q. Okay, so if a figure does not have congruent diagonals, then it is not a rectangle. Okay, and that is in chapter 2. For 6, it says give a counterexample to the following biconditional. Okay, if it is a biconditional, it has to be true forwards and backwards. So for this one, it's Felipe is a swimmer if and only if he is an athlete. So this means if Felipe is a swimmer, then he is an athlete. If Felipe is an athlete, then he is a swimmer. This is the statement that you could prove false because he could be an athlete and not a swimmer. So I said, oh, he could be a basketball player. Okay, any other sport you could put down with that as well. All right, now this one, a lot of us didn't know this off the top of our head. So which statements are logically equivalent? First, what does that mean? If they're logically equivalent, that means that both have the same truth value. So if one is true, the other is true. If one is false, the other is false. So the conditional statement and the contrapositive are going to have the same truth value. If the conditional is true, contrapositive is true. If conditional is false, contrapositive is false. And then the converse and the inverse. Okay, so if converse is true, inverse is true. If converse is false, inverse is false. This says to write a biconditional. So a biconditional has the form P if and only if Q. So it says if it is Sunday, then it is the weekend. Okay, so the way you'd write it as a biconditional, it is Sunday if and only if it is the weekend. Okay, so remember, you can think of this as your P statement, and then this is your conclusion. It is the weekend. This is going to be your Q. Okay, so the if and only if goes in the middle. This is determine the truth value for the biconditional in number 8. Okay, so the conditional is true. The conditional is if it is Sunday, then it is the weekend. Would there be a counterexample where it's Sunday and not the weekend? No, if it's Sunday, it's the weekend. Okay, the converse is if it is the weekend, then it is Sunday. That is false. What is a counterexample? Saturday. All right. Okay, so the counterexample would be Saturday, so that's why it's going to be false. Remember, if one is false, the entire biconditional is false. All right, let's go to our next one. So 3 and 4. Okay, so for A, name a pair of corresponding angles. Okay, you can have any of these pairs, 1 and 5, 2 and 6, 4 and 8, 3 and 7. Okay, those are all of the pairs of corresponding angles. Okay, name a pair of alternate interior angles, 3 and 6 and 4 and 5. Those are the two pairs. Okay, these are all in chapter 3 if you need to draw like a diagram and then write down which ones are corresponding, alternate interior, alternate exterior, same side interior. Now, for this one, sometimes people just see these and they set them equal to each other and try to solve. Okay, that's not the case with these. These are same side interior angles. And same side interior angles are supplementary. Okay, which means they equal 180 when you add them together. So you have to add them together, set them equal to 180, solve for x. Okay, for 3, find the side lengths of the triangle. Okay, we know that these two are the same, so these are the only two that you can set equal to each other to find x. Okay, once you find x, make sure you're reading the question. This said to find the side length, so I have to plug that back in. Okay, so when you plug back in 9, you're going to get 23, 29, and 29. Okay, for 4, what is the value of x? Now, we can see that this is an equilateral triangle. If it's equilateral, it's also what? Equiangular. If it's equiangular, then all of the angles equal 60. So this one you could decide. Okay, we know that this has to equal 60 in an equilateral triangle. So you could set 8x plus 24 equal to 60 and solve for x. Or I know some of you added, like you labeled each one as 8x plus 24 and then just added that together and set them equal to 180. That's fine too. You get 24x plus 72 equals 180. Again, you'd solve and you'd get 4.5. Okay, for the next page, this is another theorem that you might want to write down because I think some of us forgot about this. This is the exterior angle theorem. Okay, so the exterior angle is equal to the sum of the remote interior angles. And then remember we talked about, remote, if you're on a remote island, right, you're away from something. So this is away from the exterior angle. So my exterior angle is 126. That's going to be equal to the sum of the remote interior angles, which are J and H. Okay, it's the two angles not touching the exterior. Okay, so then you add up your like terms. 6 and 5 is 11. Negative 1 and 17 is 16. Then you're going to get all your numbers to one side, variables to the other. X is 10, but it's asking me for angle J. So I'm going to plug 10 back in. And then you'll get 67 degrees. Okay, 6 says use the third angles theorem to solve for angle F. The third angles theorem says if two angles are congruent to two angles in another triangle, the third ones have to be congruent. So you're going to set these two equal to each other. Don't worry about the y squared. Once you move all of your y squares to one side and get it by itself, you're going to have y squared is equal to 36. And then you're going to take the square root of both sides. And then when you take the square root, you will get plus or minus 6. And that should be your answer for this. The reason why you can have plus or minus 6 here is because if you plug back in the negative, what happens? What's negative 6 squared?
36.
Positive 36. Okay, and then for this one, if you plug in negative, it'll still be positive. But if you plugged it back in and it was negative, you'd reject that answer. Okay, for 7, find the measure of angle ACB. So if this is 76 degrees and this is 90, you can take 90 degrees and minus 76. You could also do 180 minus 90 first, which is 90, 90 minus 76. And then these are congruent because they are what type of angles?
Vertical.
Yep, these two are vertical angles. Okay, and vertical angles are congruent. Okay, why are the triangles congruent? Remember, if they share a side, these are congruent by the reflexive property. Okay, so then I have side angle side here. And then if I'm going to find the value of x, because these are congruent, I can set them equal and then solve for x. Okay, for 9, find the measure of angle B. So because these two are marked the same, we can use the isosceles triangle theorem, which tells us that the angles across from the congruent sides are equal. So this also has to be 2x. Then we know that all of the angles added together are 180. So I have 8x equals 180. Divide by 8 to find my value for x. Plug it back in. So if it's 2 times x, 2 times 22.5 is 45. Okay, for 10, so guys, there's no way that I'm just giving you credit if you only write parallel, perpendicular, or coincide. The only way that you're going to know that is if you find the slopes. So you have to make sure that you're showing me how you're finding your slopes here. So they give you the 2 lines, so to find the slope, and if you don't know your slope formula, that'll be something you want to put on your note card. I wrote it right here. y2 minus y1 over x2 minus x1. Okay, this is to find the slope when you have 2 points. Okay, and then the slope of NP, I used N and P. 4 minus negative is going to turn into plus. 0 minus 5 on the bottom, so I have 7 over negative 5. For QR, I have 3 minus negative 2, minus a negative turns to plus. 4 minus negative 3, that's going to turn to a plus, so I have 5 over 7. Okay, so then to determine if they're perpendicular, you can either ask yourself if they're opposite reciprocals, or if you multiply them together and they're perpendicular, what will that equal? Negative 1. Okay, so I multiplied negative 7 over 5 and 5 over 7. 7 times 5 is 35. That's going to be negative on the top. 5 times 7 on the bottom is 35. When you divide that, you get negative 1, so that means that they're perpendicular. If they're parallel, then they're going to be the same slope. Remember, same slope, different y-intercepts. Okay, if they coincide, then they have the same slope and the same y-intercept. Okay, so some of you might want to take a look at that page in your packet. It has like 24, 25, 26, 27, 28 in it. Because that was the page that most of us were missing some work. Remember, this is y equals mx plus b. B is the y-intercept. So if you need to find out if they're parallel or coincide, you can always solve to find your y-intercept. Okay, if you know 2 triangles are congruent, you know that the angles Q and G are congruent by CPCTC, which means corresponding parts of congruent triangles are congruent. All right, and then the last one, which hopefully was the freshest in our minds, was your 5 and 6. Okay, so for number 1, you're finding the measure of BC and AC. Because you have BX, that is perpendicular. Okay, if it was turned in, I gave it back to you. So you guys double check and make sure that you don't have it in your packet or in your folder. But not all of you turned it in because I just checked it. All right, so for this one, if you have CX that's 1.1, then X to A is also going to be 1.1. And A to B is 3.2, which means B to C is also going to be 3.2. So AC is going to be 2.2. Okay, so you'd add those two together. Okay, so if this one's 3.2, BC is 3.2, these two are also going to be congruent. So then you're going to add them together. All right, for 2, this here is the centroid. So remember that the rule with the centroid is if you have the median, okay, the point that goes from the centroid to the vertex is going to be 2/3 the length of the median. Okay, and then so 2/3 times 6.6 is going to be 4.4. That's how you get your answer. I would definitely write down the Pythagorean theorem. A squared plus B squared equals C squared. And then we have to know that you can use that with any right triangle. Don't try to use the 30, 60, 90 rules or the 40, 45, 90 if those two angles are not present. That's when you're going to have to use Pythagorean theorem. The side that goes by itself is always the hypotenuse. So in this one, you're given the value for the hypotenuse. In 3, you're going to have to solve for it. So 3 squared is 9, 6 squared is 36. Add them together to get 45. If you're answering in simplest radical form, then you want to find the biggest perfect square that goes into it and simplify. If you get to a point on your exam and you, if it is a multiple choice question and not a free response question, you could multiply 3 times root 5 and make sure that it equals the square root of 45. You could compare the decimals if it was multiple choice. Harlan, you with me?
Yeah.
Okay. So for number 4, you should have 9 squared on the side by itself. You're going to subtract 9 from both sides. You get 72. 36 is the biggest perfect square. Square root of 36 is 6, so you have 6 root 2. Again, when you plug in the square root of 72 and you do that calculation with your calculator and 6 square root of 2, those decimals are going to be the same. Yeah, Kate?
Should, when you like carry out the 72, does it have to be like the greatest?
Yes, or you'd be able to keep going. So did some of you realize right away that 9 went into it? Okay, so then you'd have 3 root 8. What perfect square goes into 8? 4. So yeah, so this would be 3 times 2 times root 2, which would lead you here as well. Yes, so you would just have to do this simplification one more time. All right, for the Pythagorean triple, a Pythagorean triple is going to be 3 whole numbers that satisfy the Pythagorean theorem, which is a squared plus b squared equals c squared. Here are some common examples. Okay, but again, it has to be 3 whole numbers. So if it's a multiple choice question and it's asking which one's a Pythagorean triple and you see a square root or a decimal, cross those out right away. Okay, they have to be whole numbers. For 6, a lot of you, I had you go back and write down your rules for these. Okay, so this might be a good thing to put on your note card. For 45, 45, 90, the hypotenuse is equal to the leg times the square root of 2. For this one, you were given the hypotenuse. So when you plug that into your equation, you have to solve for x. If you want to write this out, if you're given the hypotenuse and you want to solve for the leg, you can just write this as the hypotenuse divided by the square root of 2 equals the leg. That would be fine. You just have to remember to rationalize, which means if you have the square root on the bottom, you can't leave it there, so you have to multiply the top and the bottom by the square root of 2. So on the top you have 5 root 2, on the bottom root 2 times root 2 is 2. For 7, you have your 30, 60, 90 rules. So we know the hypotenuse is going to be the short leg times 2, or double the short leg. And then the long leg is the short leg times the square root of 3. You always know what the short leg is because it's across from 30 degrees. Hypotenuse is always across from what angle? Right angle. Okay, and then the long leg's across from the 60. All right, so then if this is 24, half of 24 is 12. And then so then this would, the long leg is just 12 times the square root of 3. Here's some more equations I would write down. The sum of the interior is n minus 2 times 180. I would also make sure I label that part on my note card, that it's the sum of the interior. If you have to find each interior, then you're going to take the sum formula and divide it by n, which is the number of sides. And if you have to know yourself and be honest with yourself. Are you going to know what n means, or should you write out the number of sides? Okay, so some of you might want to just write it's n minus 2 over 180 divided by number of sides. Okay, for 10, you're going to add these all together, set them equal to 360, because these are the exterior angles. The sum of your exterior angles is going to equal 360. That might be something you want to write down. And then this was a decimal. I just rounded to the nearest tenth. Okay, and then for 11, in this parallelogram, find the measure of the angle. Are these angles consecutive or opposite? Consecutive. If they're consecutive, then they are supplementary. If they are opposite, then they are equal. Opposite or equal, consecutive or supplementary, which means I have to add these two together, set them equal to 180 in order to solve for x. And then it says to find b, so once you find x, you're going to plug that back in.